Okay, so we're going to look at problem 7.8 and 7.9, and if we get 7.8 set up in an Excel spreadsheet, we can use that same spreadsheet with a few modifications to do 7.9 as well. So this is ordinary earth will be excavated and hauled by scrapers whose capacities are 14 cubic yards struck and 18 cubic yards heaped. Loose measure. The distance from the borrow pit to the dump site will average 2,680 feet over a level earth haul road. The scrapers can average 15 miles per hour loaded and 20 miles per hour empty. The fixed time for the scraper, including loading, dumping, turning, waiting to load or dump, etc., should average about 2.5 minutes per trip. Assume an average capacity of scrapers of 16 cubic yards loose measure. Use a swell factor of 25% for the ordinary earth. One dozer will be used to assist the scrapers in loading for this project. Determine the number of scrapers that one dozer can serve. It's expected that it will require from 50 to 70 seconds to load a scraper with the assistance of a dozer. Thus, a dozer should be able to serve a scraper about every 2.5 to 3 minutes. Assume a 50-minute-hour efficiency and estimate the cost per cubic yard using this information. So we have the scraper's cost, dozer cost, and the operator's cost. So basically what we're going to be doing is as always, the first thing we do is go in and take all of these variables that we had in the problem, and we want to enter them into the spreadsheet just so we have all of the variables there, and then we can kind of figure our calculations that we want to set up. So the things we'll probably figure out are cycle time of the scrapers, the production rate of the scraper, the number of scrapers served by one dozer is one of the things they're asking about, and then we also want to know the hourly cost of the earthwork operations. So scraper, scraper operator, dozer, dozer operator. And then finally we're going to try to figure out the cost per cubic yard for bank measure, and then for loose measure. So as I said, let's just get started out and put in the variables that we have. I have placed most of these variables already. We have 14 cubic yards struck for the capacity of the scrapers. We have 18 cubic yards heaped. The average capacity they said was 16 cubic yards. The speed of the vehicles, loaded 15 miles per hour, empty 20 miles per hour. And then over here I put in the crew cost for the scrapers, 68.25, dozer 59.50, and those numbers are all just from right here. And then the first paragraph we get the capacities, the miles per hour, the trip distance. So dozer, the time to load a scraper takes 70 seconds. The scraper served is served in 3 minutes, and in other words the dozer can do this in 3 minutes. They said 2.5 to 3 minutes. The hour efficiency, also they told us that we're going to be working 50 minute hours. Distance to the borrow pit, they gave us that, 2680, put it in there. Fixed time, 2.5 minutes, swell factor 25%, and then just for our purpose of the calculations, a mile is 5280. I don't know if you hear a lot of times to remember that Denver's they call 5280. There's a magazine 5280. It's a mile high, the Mile High City 5280. If you can remember that number, you'll see it around. But so 1 mile is 5,280 feet. So what we are going to do then is figure out the haul speed, return speed. So this is the cycle time of the scraper. Haul, return, time to load, and then our total cycle time. So the first thing for the haul speed. With the haul speed, they gave us, we know that it's going 15 miles per hour, and that 1 mile is 5,280 feet, and then we're just breaking it down. We're going into feet per minute, so we're doing this right here, 1 divided by 60 just gives us that feet per minute equation. And then so that's the haul speed, right? It was 15 miles per hour because it was loaded. Now on the return speed we're going to go ahead, very similar equation on the return speed. We're going 20 miles per hour, and that's 5,280 feet per mile. We're doing feet per minute, so 1 per 60 seconds, and that'll give us that rate. So 1,760 feet per minute is how far it goes. So return speed, the haul, just basically 1,320 feet per minute divided by the distance of 2,680. Same with the return. (2,680 feet) is the distance to the pit. On our way back, we can drive 1,760 feet per minute. So it's just a matter of getting these in the right and consistent units. So time to load, they gave that to us. It was a fixed time of 250. So our total cycle time, and I just summed up these: the haul, the return, and the time to load, their back load, at 6 minutes and 5/10 of a minute. So then, or 5/100ths. So then, on the production rate of the scraper, how we prefigure the production rate of the scraper is that we're going to go ahead and we're going to look at the total cycle time, and then in here is where we factor in the efficiency rate for our scraper, because we're working 50-minute hours. So we just take 50 divided by 1, which is essentially 1 hour, and then our cycle time, 1 trip, divided by the cycle time, 6 minutes. So that gives us, we can make essentially 8.26 trips per hour. And you may want to format these, just take the decimals down a little bit. Oops, I guess I'm taking them up. Just kind of clean it up. It entirely depends on you. On the dollar amounts, I would use the dollar amounts in the formatting. So then on the production rate, so we're also figuring the volume here. And if you look at what the average capacity of the scraper was 16 cubic yards, and we just multiply that by the number of trips per hour. So we know how many cubic yards of loose measure that we're moving, 132.17 cubic yards per hour of loose measure that we're moving. Capacity of it times the capacity of the scraper by the number of trips per hour. So then we factor in on the bank measure, we just factor in the swell, which we put in here at the swell factor of 25%. So that bank that we're actually excavating or that we're moving is going to swell up essentially. So that's what we're doing, is just taking the volume per hour of loose measure, 132, and then we're dividing it by the 1.25%. So 25% plus 1.25. We're dividing it just to get the bank measure. So then we're kind of figuring the number of scrapers served by the dozer is what they were asking us, and they said that these would work between 2.5 and 3 minutes. So just doing an average, we're averaging it. 2.5 minutes plus 3 minutes divided by 2 is going to give me 2.75 minutes on average for the average dozer cycle time. And you could use more if you're out on the site and you're timing equipment. You could take 10 measurements and divide it by that just to get more accurate time. For our purposes, they gave us a range, and we're just going to use the middle number, 2.75. So the average scraper cycle time, we figure that up here. Average scraper cycle time is 6.5 minutes. So we're figuring how many scrapers can the dozer serve. And essentially what we're doing is we are taking the average dozer cycle time and we're using that to divide. We're dividing that by, or we're dividing the average scraper cycle time by the average dozer cycle time. So what we get is 2.2, and what we're going to need to do is probably round down in this, because we only have we don't have 2/10 of a dozer, so we're going to round down to 2. So two scrapers can be served by one dozer. Well, how does that factor in, or why does that factor in? That's going to factor in here when we're figuring the hourly cost of our earth operations. So we're going to treat, since it's an hour, two scrapers are served by one dozer. We could then just think that half a dozer serves one scraper when we're figuring out this hourly cost. So we were given this number, 68.25, and I here am using these we put in, these were given. I'm setting up my formula now. This is going to equal the number I put up for the equipment cost. And I'd actually say, I said crew cost, let's call this equipment operation cost. So then the scraper operator, 21.25, either of these operators is 21.25, and then we figured that the dozer we're going to do times a half. So there's the dozer, and I'm just dividing it by 2 because one dozer will serve 2 scrapers, and we're just figuring the hourly cost here of one dozer. You can either multiply 0.5 or divide it by 2. And then the dozer operator did the same thing and then divided by 2. So our total cost here is $129.73. Yeah, I just summed those up. And then, so the bank measure, so our cost per cubic yard. So if we're going to figure the bank cost, essentially we just go, we get the cost, $129.23 per hour, and then earlier we calculated that the swell or the bank measure was 105.73 cubic yards per hour. So what we're going to have then is the cost per cubic yard, and that's $1.23. On the loose measure, it's going to be 98 cents per cubic yard. So 129 divided by 132, $129 dollars per hour. So 132 cubic yards per hour. Hours cancel out. So that gives us our 98 cents per cubic yard. So those are the answers that you're looking for in this problem. 129.73 is our cost per hour for the earthwork operations. These would be our costs per cubic yard, and those are correct. So now let's take a look at this. I'm going to just set up a new sheet, and I'm going to copy this formula, and we're going to look at problem 7.9. So let me just copy this, and we'll paste this over here. So let's take a look at 7.9. 7.9 is similar. When we look at this problem, it's an 1,800 foot haul. That's something that we could change. 1,500 cubic yards of loose measure. They're self-loading scrapers. They travel 12 miles per hour and 18 miles per hour, 2.5 minute per trip, 50-minute hour. So a lot of the same factors. Swell factor is the same. So let's go in and let's put in these costs, $94.50, $22.75, and let's get rid of that dozer and put in a foreman instead of the dozer. So let's go ahead and put a foreman in. And so the scrapers were, they said, $94.50 an hour. The foreman cost $28.40 an hour. And the operators were $22.75 per hour. So then what else are we going to change here? 14 and 18, this was average capacity here was 15 cubic yards, and then they said that they loaded this one traveled at 12 miles per hour and at empty 18 miles per hour. We have our scraper operator. Get rid of our dozer operator in this formula. And we'll just delete that. We don't need to do the... We're just figuring these for 4 hours, full hours. Then we have our foreman. And I'm just going to make our foreman equal our foreman cost. And we're at 145.65. The other variable that changed was the distance. The distance was 1,800 feet. So that actually is all it took. And we have the correct answers here. So the bank cost is $1.30, the loose cost is $1.40. And so essentially we just went back in, changed some of the operating costs of the equipment, had a foreman instead of a dozer and a dozer operator. We had a little bit of a difference on the distance to the borrow pit. So basically just need to carefully look at in 7.9, you just need to take your time and carefully look at the variables that changed. Of course, every one of these sheets is dynamic, and you probably recreate a lot of them in the real-world situation. But we're basically working on cycle times, production rates, and equipment costs, and then we get into the cost per cubic yard and our hourly cost to operate. So that is it. If you have any questions, you can call me at my office, and I'll be available. Thanks so much.